everyone would, could please mute their speakers. But if you have questions during my talk, then put it in chat. And then Bruce will be the one that will interrupt me to say if it's a really good question. So I know it's any question, and we can stop as we go. So I'm going to start the screen now. Oh, and by the way, I wasn't a pilot in the Air Force. I developed technology for the Air Force, mostly sensors, radars, lidars, electro-optical stuff. So we were, wherever I was working, we were usually looking into space. So anyway, and I've been to Area 51, if that means anything to anybody. So, but in any event, so here we go. Okay, so you should be, oop, wait a minute, what's wrong with this? There we go. So now we're on full screen. So basically this question asks, are we the only intelligent species in the universe? Homo sapiens, that's our genus and species name. So, oop, I'm gonna stop this here. I'm not gonna start it yet. This is three class, where they were classified, they're declassified UFO videos taken by Navy pilots in, let's see, there was one in 2004 and two more in 2015. And MSNBC put these three videos together and published this. I think it was in about 2 years ago. In 2019 is when this got on TV. So. Oh, they're going to use an acronym here. ASA, that's Advanced System Avionics. It's not a swear word or anything.
There's a whole fleet of them. Look on the ASA. My gosh. They're all going against the wind. The wind's 120 knots from the west. Look at that thing, dude.
Let me just pause it. Can everybody hear that? Can you hear that, Bruce?
Yes, I can. Well,
okay, great. Okay, good. I connected and shared my screen properly. Okay.
Let me ask you a quick question, Larry. I'm recording this to the cloud. Is that the right place to put it?
Yes, it is. It's to the cloud, absolutely. And then that way, we can work with Lisa and actually post it wherever we want to. You're right. Okay, so here's our unidentified objects. Oh, come on. Stop this. There we go. Okay. So, so here's the agenda. There's going to be a brief history of UFOs, also known as unidentified aerial phenomena. You notice there's no S there because phenomena is plural. We're going to talk a little bit about where we live. Then we're going to talk about the speculation about extraterrestrial life, just a history of that from about 600 BC to today. Turns out there is an equation for that now. And we'll talk a little bit about SETI. And then we'll have concluding remarks. And that, so I'm going to try to do all of this stuff with just nothing but the facts, ma'am, kind of approach. And then here's where I may give a few of my own opinions, and then we'll have questions and discussions. So the way this is going to work, whenever I get to a new topic, I'll have everything else grayed out, and then that's what we're going to talk about next. So we're going to talk about UFOs in America. Now, there's plenty of other reported UFOs around the world, but I'm just going to stick to America. So the first time, actually, we have to go all the way back to the Pilgrims. John Winthrop, you may or may not know, he was the governor of the Massachusetts Bay Colony. Yep, that one. That was the famous one, right, with the Pilgrims. He wrote in his diary about an unusual event that caused quite a stir among the English immigrants. There were about 1,000 people there, I think, at the time. And 3 men in a boat at night were going down a tributary to the James River. It was called the Muddy River, and they were going to the James River. And this light darted back and forth on the river between the boat and the village, which was about 2 miles away. And it did that for several hours before fading away. And John Winthrop said, hey, these guys were sober, upright, God-fearing men. And so, whatever happened, that's what they saw. Also, when the ufologists looked at the diary writing, Winthrop had noted that the men, when the light faded, they realized that they were a mile or maybe even 2 miles upstream of where they started, but they don't remember rowing. So some of the ufologists say, well, that was the first alien abduction in the United States. So now we're going to go all the way up to World War II in the Battle of Los Angeles. I don't know if I never knew about this actually until I started to look into the history of UFO claims. Oh, I don't know, maybe 15, 20 years ago I did that. There was presumably an enemy aerial attack, and there's a whole subsequent anti-aircraft artillery barrage. And it lasted for 4 hours. I don't know where all of the shrapnel and everything came down, but there's no reports of that. But anyway, the next day, the Secretary of Navy said it was a false alarm, but the ufologists claim it was an ET spacecraft. The official report from the Army was that they had launched a weather balloon, and that's what caused the problem. So now you go after World War II to Murray Island, Washington, and there was a very highly publicized sighting of 9 UFOs. They were flying at tremendous speed. Today we would call it hypersonic speed. That's how fast this pilot reported. It was widely carried by the Associated Press. And in the history of this UFO sightings, it serves to be the catalyst for UFO interest in the country. Just about 2 weeks after that was the very famous Roswell incident. And here the claim is that an alien spacecraft crashed. Dead aliens were actually recovered by the military. The military claims it was a top secret research balloon, but they didn't want to talk about it, obviously. And of course, now Roswell's an international tourist attraction. Go one more year further ahead, early 48, just 6 months, I guess, earlier, in Marysville, Kentucky, there was an Air National Guard pilot who saw a UFO. It was he didn't know what it was, so it's an unidentified flying object, and he chased it. And during the chase, he crashed his plane. And now, for the first time, UFOs are considered dangerous, and they were taken seriously actually by the press. Before this, the press just kind of, oh man, these crazy people. But now it was taken seriously by the press. And for about more than 2 weeks over Washington, D.C. skies in 1952, a whole bunch of UFOs were reported over the city, just about one a night. But in any event, because of this, the CIA started something they called the Robinson Panel. And the public, release for making this Robinson Panel was to reduce interest in UFOs. That was what they were trying to do. What they used it for, though, is a cover to spy on UFO organizations. And then for September 19 and 2053 in rural New Hampshire, Betty and Barney Hill was abducted. It was the first widely publicized alien abduction report, and they couldn't really remember it until they were hypnotized, and so they had recovered memories. And so that was really the first time of reported of alien abduction, was in 53. Of course, remember, there's still people that think that these guys were abducted and then put back in their boat. But in any event, so now we go to 73, and there was a Pascagoula abduction. Charles Hickson and Calvin Parker, they claimed to be abducted, and that was one of the best known cases. Not as well known as the Betty and Barney Hill abduction, but certainly like number 2. Okay, and then after that, there's been all kinds of abductions by aliens. In 1980, in Dayton, Texas, there's the Cash Landrum incident. So, and this is the one of the very few UFO cases that actually resulted in civil court proceedings. And ufologists consider it to be a close encounter of the second kind. So there's first kind, which means you see something in the sky that's, unidentified. Second kind means that you were actually, there was some sort of reported effect, right? Something happened, maybe interference in your radio, or a light bulb popped, or something like that. That's second kind. Third kind is where you actually see an alien and communicate with them in some way or another. And there was effects on the witnesses. Their car headlights blew out, and anyway. So that's that happened in 1980. In 97, in Phoenix, it's called the Phoenix Lights Incident, because it was reported by dozens of people, but in varying ways. In other words, how they described the lights varied from person to person. But the lights started at the Nevada-Arizona line, went more or less straight, went all the way through Phoenix, and then to the edge of Tucson. Still don't know what caused it. Highland, Illinois, it's called the UFO over Illinois incident. About 12 years ago, there were hundreds of people in 6 towns, and they reported seeing a massive, silent, triangular aircraft operating at an unusual range of speeds, from near hover speeds to very high speeds, and it all was about at treetop levels. Now, you may have actually seen one of these reports that were produced by, one was by ABC, one was Discovery Channel, one was Sci-Fi Channel. All 3 were different. But they were all in the same incident. And so anyway, you could probably, I don't know if you could get it today or not. I don't know. You'd have to look and see. But anyway, I didn't see it. I didn't have a chance to see it. But I know people who looked at least one of these hour-long special reports. In 2007 in Honolulu, several people saw UFOs, and a TV station videoed the objects with a sky cam, and the National Weather Service and the FAA, they didn't see anything on their radar. They said, yeah, we didn't see anything that was at that particular time. In 2014, there were lights in the sky over Houston, and they were seen by a few dozen people. They were photographed and videoed, also unidentified. And the last one I have is in the Clayton, New Mexico. The Clayton UFO incident was an American Airlines pilot. He was at 37,000 feet, and he radioed to air traffic control that there was a long cylindrical object over his plane, flew over his plane at high velocity at just about noon local time. He guessed it was probably close to 50,000 feet. And the FAA said they saw nothing on their radars. So there you have. Now, this is not by any stretch of the imagination. I don't mean to imply that these are the only sightings. I just start with the first one, and then the ones of more interest, or milestones, if you will, in UFO, UAP reports. Any questions so far on chat, Bruce?
No, there's not, Larry.
Okay, all righty. Okay, So remember, folks, if you have a question, just put it in chat and then we'll figure it out. So so now what we're going to do is we're going to look at a little bit about the universe we live in. I mean, if we have, let me back up, if we have all these unidentified flying objects and everything, where are they coming from? So let's talk a little bit about the universe we live in. So now there are a lot of people who really, really believe that aliens routinely visit Earth, and some people even believe that aliens live among us. These people think that Men in Black movies are either intentionally or unintentionally are documentaries of the real world. Any event, so let's consider the universe. We live in a solar system of less than 10 planets. I'm not going to get into the argument of whether it's 8 or 9 or whatever, but it's less than 10. They lie more or less in a single geometric plane, and they orbit a star that we call the sun. Only one planet is known to have life, but life might have existed in the past on Mars, maybe, and it might now live on some of the moons of Jupiter and or Saturn. But there's for sure, if there is life, we haven't communicated. There's no communication with life in the solar system, other life in the solar system. Now, our solar system does seem really big to us. Okay, I mean, it seems really big. The furthest reaches of our solar system lie beyond Pluto, something called the Oort cloud, which is where all of the comets, the ice balls, hang out in a sphere, really, around our solar system. And occasionally, one of them will get nudged by, a gravitational perturbation, and it will fall to the sun, and then that ball of ice becomes, to us, it appears to be a comet. It's 4.6 trillion miles away. That's pretty far, but it's less than 1 light year. A light year is about 5.88 trillion miles. So even the Oort cloud is not even a light year away, but that still seems, that's pretty big to us. Now, consider this, that the Voyager 1, which was launched in '77, and it's been going about 38,000 miles per hour ever since, means it's 14 billion miles away. Remember, 4.6 trillion. So it's not even anywhere close to the Oort cloud. But in 40,000 years, it will have a close encounter with a star that is like about 17.5 light years distance. Now, a close encounter means it's within 1 light year of that star. That's the nearest big thing that's going to be approaching after 40,000 years. But so if we were on Voyager 1 and we were going in that direction, we wouldn't see anything, get close to anything large, to another planet or anything that might be presumably orbiting that star for at least 40,000 years. Now, our solar system resides, it turns out, and we didn't know this, until relatively recently, in one of the spiral arms, an outer spiral arm. The arm is named Orion now, of the Milky Way galaxy. The galaxy itself consists of about 100 billion stars. So our sun is one of 100 billion. And there are 200 billion galaxies in the universe. That number, by the way, has decreased from 2 trillion. We thought there were between 2 and 20 trillion galaxies, but the New Horizons satellite, the probe that just went past Pluto, it sent back new estimates of the number of galaxies, and it's probably pretty close, best guesstimates now, about 200 billion galaxies, which means there's 20 million trillion stars in the universe.
Hey, Larry.
Yes.
Paul Erickson wants to know, do we still get radio signals from Voyager 1?
Yes, we do. And the radio, okay, so we launched Voyager 1 in and Voyager 2, actually. They were a couple of months apart, but they took different paths, so that's why. But Voyager 1 took a more direct route, so it's further away. But it uses radioisotopes for its power, not solar energy. We don't launch many of those anymore, and it its radionuclear power plant that it has, this little pile of nuclear stuff, will run out in about 2025. So we still get downloads from the Voyager 1, but that will stop sometime during 2025, unfortunately. But if you're a believer in Star Trek, Voyager will come back. If you saw that episode or that movie, I guess, in Star Trek, Voyager will return. But in any event, yes, but the Voyager 1 is still transmitting back, and we still have a satellite that's big enough that can pick it up. You can imagine it's pretty faint. So, okay. So we got that many, there's a lot of stars in the universe. And so here we are. So this is, now you have to reconstruct we don't have a probe that's, I don't know, this is probably 40 million light years away from the center of the Milky Way galaxy here. So we have to reconstruct this images like this. But so this is a pretty good reconstruction here. You can barely see in this particular artist rendition, or actually it's computer generated based on the locations of stars. You can see the spiral arms, but we're right here, okay? And that's where the Orion arm is, the spiral arm. There's a better view here. You can see the view. So the Orion arm is this kind of little guy between Sagittarius and Perseus arm. But that's where we are right there. Now these red things, those are other galaxies, okay? And they're just points, okay? Because they're so far away, that's, unless you have a really big telescope, or one of these galaxies are close, like Andromeda, say, they're just a point in the sky. But in any event, and then now I'm going to, this is from the American Museum of Natural History, this thing. So you can watch this video. Oh, by the way, this starts in Tibet and then goes out from the galaxy at increasing speeds until we get as far away as we can, and then it comes roaring back. Slows down when it gets close to our solar system. You see the Earth is tilted on its poles. That gives us our seasons. We are the third rock from the sun. You see all the planets lie more or less in one geometric plane. The stars we see in the sky are very near to us relative to the rest of the Milky Way. we started radio, that was strong enough to get out of our galaxy. That's the extent of our radio frequency outside of the galaxy. Now we're going way out, and we're going fast. All those little dots are a separate galaxy. The holes are caused by the galactic core. We can't see through it. And that's our extent. 13.7 billion years is our horizon in space and time. Now we're screaming back to our Milky Way, to the Orion Arm, to our solar system, to the planet Earth. And we're going really, really, really fast. There's the Milky Way. Here comes our sun, and we're going to have to blank that out. We won't see anything. There's our solar system. There's the third rocky planet of the sun, after Mercury and Mars, which is a pale blue, tiny, tiny dot. Beautiful, isn't it? So here we go. So now I'm going to start a brief history of speculation about extraterrestrial life. Any comments by anybody about the universe we live in? Okay. Now, so we're going to talk about this, and this is all speculation up until about 50 years ago. Okay. We actually now can do some statistics. Before then, we were just guessing. So if we're going to do this, we got to go way back, though. We're going to start with Anaximander, about 600 BC. He was in a city that's now Turkey. And he proposed that Earth is a floating body in an infinite void held up by nothing, and that maybe other such bodies might exist. Now, for 600 BC, that's an amazing leap, right? Oh, I got something in chat. What is that? Oh, do we still get radio signals? I'm sorry. Yes, we do. Yeah. Okay. Good question, Paul. Okay. So, so that's pretty amazing. That some guy, Anaximander, and in fact, he wrote about it, and people, you know, they thought, yeah, well, he's crazy, but whatever. But then Democritus, which was only about 150 years later, thereabouts, in Abdera, which was in Thrace, which is kind of today, Thrace is sort of like Greece and, um, uh, you know, parts of Turkey. And, but in any event, he formulated the idea with his students of atomism, or the existence of atoms. And he believed that there were an infinite number of atoms, and if these atoms combined and, you know, crashed into each other and stuck together, they would form worlds. And so he believed in an infinite number of atoms and therefore an infinite number of worlds. Now, Plato and Aristotle, who came after him, not by far, you know, 40, 50 years, they were both highly critical of Democritus' atomism concept, which in fact turns out to be pretty, not bad, pretty close to what we have today. But it took us, you know, 2 millennia to figure it out. But Plato and Aristotle, who, by the way, they were not scientists, right? They were thinkers. They thought that trying to actually do an experiment was something that was beneath humans. We should just think about it and come to the best conclusion. Of course, Democritus didn't have any evidence either. Okay, but then you know, after Plato and Aristotle, there was a guy named Epicurus. And he was born in Greece, and he was a firm atomist. And so he took up Democritus's and his students' belief that there's an unlimited number of worlds, and some are similar to this one, and some are dissimilar. So the Epicurean view of the universe held that aliens must exist. Okay. Now they had no idea, of course, about the universe. Didn't even really know what stars were. Didn't have any clue as how far away they were. Now, the important thing about Epicurus, even it turns out, even though we know something about him, he had a student named Lucretius, and he wrote a book-length poem about these concepts. Okay, a book-length poem about this multiverse, this multi-world universe that in which aliens should exist. And we'll get back to him later. So now, of course, now we come up to the time of Christ, and the early Christians just tossed the Epicurean packages, extraterrestrials and all, into an abyss of doctrinal errors. Now, there were a lot of doctrinal errors that got tossed out, as we know. But as Christianity then swept across Europe, the church suppressed the Epicureans and their ideas. So most of their books were burned or allowed to just rot away. And so the whole idea slipped into darkness for about 1,000 years. But then we get to a Florence scholar and who's also a book collector in 1380. Poggio Brassolini. If you you can get pronunciations if you put that name in, you know, and you put any name in and you say pronunciation, you'll get to a pronounce-this-name.com or something. And my Italian is very fractured, but anyway, he's a pretty well-known guy, actually. He was a pretty influential scholar, but he found this book-length poem by Lucretius, this, you know, Epicurus' student. He found it in a German monastery in 1417. Now, of course, you know, now we had, you know, Gutenberg and everything. So within 60 years, hundreds of copies of this had been printed, and that reignited interest in Epicureanism, which some say actually helped spur the Renaissance. And there's a literary scholar in Harvard who argues that the poem's atheistic and materialistic ideas served as a catalyst for Renaissance humanism, which he called an inquisitive philosophy that began to question humanity's privileged station in the cosmos. Now, whether or not, you know, the Renaissance is due to, you know, was spurred on by this book that Brassolini discovered, is relatively irrelevant, because the Renaissance did see growing interest in the idea of the plurality of worlds. and its corollary, of course, which is the possibility that other worlds might be populated by other beings. And Copernicus is the guy that provided one key stepping stone. Now, he was born in 1473. You know, there's the Chinese proverb that says, may you live in interesting times. This was interesting time in human history, because the same year that Lucretius' manuscript was first published, that's the same year that Copernicus was born. Christopher Columbus was 22, and Leonardo da Vinci was 21. Machiavelli was 4, and Martin Luther would be born 10 years later. So this whole thing, Copernicus, he's central to the story of extraterrestrials, but not because he believed in them, because he just didn't care. He thought the question was, he didn't bother with it. But he was the first person to propose, based on science, based on observation and calculation, that Earth was in fact not the center of the universe. Oh boy, now that shook things up. So he had this heliocentric model that the sun was the center of the solar system. And it did solve a lot of observational problems. You know, when we look up, we see retrograde planets seem to go back and forth. That arose from the Aristotelian system, or the geocentric model, where the Earth is the center of everything. But it caused a revolution, because now all of a sudden the Earth was not in a privileged central position. This principle is at the core of the modern day case for doing research related to SETI, the search for extraterrestrial intelligence or life. But okay, so that's Copernicus. Now enter Giordano Bruno. He was born in Nola, Italy in 1548. He was a Dominican friar who became somewhat of a renegade, and he conceptually extended the Copernicus's model. He wrote 3 sets of what were called dialogues. I'm not sure why they're called dialogues, but anyway, in about 7 years, that argues that at least some of the stars are in fact suns with their own planets, and some of these planets must be populated with other sentient beings. Now, how could he make that leap? Let me just back up just a little bit here, because what Copernicus did, and other people then, they discovered moons around the planets, the other planets, Saturn and Jupiter, and they were orbiting, you know, and say, wow, look at that. And so Bruno said, you know, those other stars out there, they're suns, and they have their own planets. And some of those planets have to be populated with intelligent beings. But he was asked to recant, but he refused. So he was arrested in Venice in 1592, a year after his last dialogue was published, on charges of blasphemy and heresy. He was taken to Rome. His trial lasted for 7 years. I don't know why it lasted that long, but eventually he was found guilty, and he was hanged naked, upside down, and burned to death over a fire. So much for Bruno and his ideas. Now, that got the attention of people living outside of Rome, okay? But even so, that could not prevent the emergence of a new understanding of the heavens, especially what Galileo and Johann Kepler discovered with their telescopes. Now, Galileo, being in Italy, in Pisa, he was, well, in those days, you were either Catholic or Protestant, right? I mean, you could also be Jewish, but if you lived in Italy, you were a Catholic. And if you lived in Germany, you were a Protestant. So Galileo was especially circumspect when it came to the idea of having people outside of the Earth, having, you know, sentient beings, intelligent life that didn't exist on Earth. Kepler, though, was a Protestant. He didn't have that problem. So he published all sorts of ideas and bought into this idea completely. But Galileo got in trouble anyway. He even though he didn't subscribe to extraterrestrial life, he did, you know, say, hey, you know, Copernicus is correct. And not only that, Galileo got in other trouble because he did experiments on gravity. He created vacuums And so that just got him in all kinds of trouble. And so he was under house arrest until he died. But in any event, this other Dutch Christian Huygens here, who is maybe one of the greatest scientists that ever lived. He was born in 1629, so you can see it's after these guys. And he published a book. Now, he was circumspect about what the church might think about him if he published this book when he was alive. So it was published after he died. And then he asserted that, hey, look, the stars have to have, there's just no question about it. They have to have their own planetary systems, and where there are planets, there must be people. So, and that book was published in 1698. So it turns out that by 1700, the plurality of worlds concepts seemed almost ordinary. 18th century thinkers like Edmund Hillary, Gottfried Leibniz, Immanuel Kant, William Herschel, Laplace, and Thomas Paine just accepted it as part of a scientific realist worldview. Okay, it just, but it was still incompatible with strict Christianity. So now enter William Whewell. That's how you pronounce his name here, Whewell. He was a leading 19th century scientist, but he was also a Christian. And so he either had to accept, one or the other, and he chose Christianity in his mind. And so he abandoned pluralism and published a strong argument against pluralism in 1853. And that's it's actually a really good argument, because he said, look, you guys don't have any evidence whatsoever. Show me some evidence that there's life on other planets, that there even is other planets. And so and so that's sort of where we stood. Okay. Because you could speculate all you wanted to, but we hadn't even been to the moon yet, let alone another planet. We're still not to another planet even now. So any questions so far, or comments or anything before we go on to the next step? Okay, I don't see anything in chat. So we'll go on to the next step. And, you hear this.
Sorry, that
Yes, go ahead.
Hillary in the 17th century, you talking about the guy who climbed Everest, or is that another different Hillary?
That's a different Hillary.
Okay, all right, end of story.
Yeah, this Hillary is a philosopher.
Okay.
And Leibniz was one of the guys, along with Newton, who invented calculus. And Immanuel Kant is, of course, a philosopher. William Herschel, an astronomer. Laplace is a mathematician. Of course, Thomas Paine wrote a lot of the Federalist Papers in the United States. So, okay. So, they were just, call them 18th century thinkers. So they just said, yeah, sure. I don't see anything wrong with that. But Whewell thought, no, this is bad. And so that's where we were for, and still are, really, in a sense. But so now, you heard the saying, there's an app for that. Well, there's an equation for extraterrestrial life, believe it or not. So, and it estimates the number of communicating civilizations in our galaxy. Communicating civilizations within the Milky Way, not outside the Milky Way, because we have no idea how to communicate with anybody outside the Milky Way. But or in other words, one way to say it, is what are the odds of finding intelligent life in our galaxy? So it was proposed by Frank Drake in the early 60s. And he's a radio astronomer. Excuse me for a second while I see what's wrong with my dog. She's small, but she has a large bark. And it has 8 variables in this equation. And it's usually written according to SETI, the Search for Extraterrestrial Intelligence Institute, as N, the number of civilizations whose electromagnetic emissions are detectable. So that's the number of civilizations in the Milky Way, is equal to the rate of formation of the stars suitable for the development of intelligent life, the fraction of those stars of planetary systems, the number of planets per solar system with an environment suitable for life, the fraction of suitable planets on which life actually appears, the fraction of life-bearing planets on which intelligent life emerges, and the fraction of civilization and development technology that releases detectable signs of their existence. So all of these things have to occur, right? First of all, you have to have a formation of a star that's suitable for the development of intelligent life. So a red giant wouldn't be suitable, okay? A star like Rigel wouldn't be suitable, it's too hot. But then you got to find the right star. You got to find the fraction of stars that actually have planetary systems. You have to find the number of planets per solar system that's in the habitable zone from the star, the fraction of suitable planet in which life actually appears, then the fraction of those planets on which intelligent life emerges, and then the fractions of those civilizations that develop a technology to detect that releases detectable signs of their existence into space. So that's, the problem with this, of course, is that, oh, I forgot, the length of time that such civilizations release detectable signals in space. Because if they're on the other side of the galaxy, right, that's 100 million light years, 100,000 light years away. We're not, we couldn't necessarily detect it unless they kept doing it. So now the problem, of course, is that we don't have firm numbers on any of these variables. So any calculation of the Drake equation is just at best, a rough estimate, actually just a guess. Here's a truth, a basic truism. Statistic requires a sample size of 2 or more. N has to be at least 2. If you remember anything about your statistics courses, all the equations are divided by the numerators are divided by n minus 1, where 1 is the sample size. And if n equals 1, then you're dividing by 0, so you get any answer you want. Okay, so now a sample size of 2 is pretty small, right? I mean, you wouldn't do a poll of who's going to win the mayoral race in Denver with a sample size of 2, right? I mean, you have to do statistics, and so they get the larger the sample size, the more accurate it is. But we didn't have any statistics, right? We only had 1. We had a sample size of 1. We have a planet around our sun with life in it. Now we have 8 or 9 planets, depending on how you want to count. So now we have a sample size. So at least around our sun, our type of sun, we know that there's at least one case that have planets around it, but we don't know if any other star has planets around it. But now we've had some discoveries that give astronomers a better chance of finding some of the answers to the variables in the Drake equation. The first discovery of an exoplanet, that is a planet outside of our solar system, occurred in 1995. NASA launched a satellite called the Kepler Space Telescope, and it's found a whole lot more, and so have other telescopes on Earth. And we now have 4,000 confirmed exoplanets, and there's tens of thousands more that are candidates that we still need more study on. So now, right, 4,000 is a pretty good sample size. And so now we can do statistics. And it's basically, and this number is going to turn out to be, it might be 1.5, it might be 1.7, but, it's a pretty accurate, based on our statistics, and what we know about statistics, this is pretty accurate. So on average, every star in our galaxy has 1.6 planets. So, at a minimum, it could be more than that, but this is based on what we have now. And there's which means there's 160 billion alien planets. Well, that's not bad. That seems like, 160 billion, that's in our galaxy, that's pretty good. And it's actually the Kepler Space Telescope. We can't do this with any land-based telescopes, but the Kepler Space Telescopes suggest that rocky Earth-sized planets are relatively common in this 160 billion alien planets. However, among the planets discovered by all the telescopes, whether it's the Kepler Space Telescope or all the land-based telescopes, only a tiny fraction of them are likely to have an environment suitable for life. Now you can go to this website right here if you want to, and they catalog all the exoplanets that are in a habitable zone. They list them, and they have about 60 right now that could optimistically be suitable for life. And, you know, some are really out on the edges there. But among those, 23 are more likely, at least, to be habitable. So that's the Drake equation, and this is where we are. Now we have some data. We have what Whewell would call empirical data to suggest that there could be extraterrestrial life. And so his arguments that he made in 1853 are at least now debatable. That is to say, we can say, yes, we have some evidence, okay? And so that brings us to the idea of SETI, okay? The search for extraterrestrial intelligence. So now this is, when it was first built, this was funded, by the way, by the DoD, okay? And it started being built in the mid-50s from DARPA, by funds from the DoD and DARPA. And what they were trying to do with this, this is a 1,000-foot disk here, diameter disk. What they were trying to do was detect rockets and missiles in the ionosphere. And so when a rocket comes roaring through the ionosphere, the ionosphere is the thing that creates the aurora borealis. And so it emits radio frequencies. And so that's what this satellite detects, is radio frequencies, you know, sort of like in the same range of an AM or FM radio. And this is in Puerto Rico. This, by the way, this telescope, if you are a James Bond fan, it was in GoldenEye. It was like, think the climatic scene of GoldenEye. It was also in the movie, I did not see this movie, but I read Carl Sagan's book, Contact, but they made a movie out of it. Apparently, the satellite and the Arecibo radio telescope had a big role in the movie Contact. And you could see that there's 3 big towers held up by, you know, all kinds of lines here. These things are not thin lines, and they suspend this movable, you know, to direct where the space this thing is immobile, but where the space telescope is actually looking into space. Okay, and so this was in 1961. It was DoD, and then in 1971, 10 years later, it was transferred from control from the DoD, and it became a federally funded research and development center, or FFRDC, and it was controlled or managed by NASA from 1971 to about 2000, when it was turned over then to the National Science Foundation, the NSF, in about 2000. So it's no longer an FFRDC. It was a National Science Foundation project. But it was never really used for its original purpose, which was to detect rockets with traveling through the ionosphere. So because there are other ways, you know, it became overcome by events, other technological advances, and we no longer needed to search for missiles coming into our country, coming through the ionosphere. We had better ways of doing that. But it turned out that you could listen to radio waves from around the world, around the universe. And so, that's where you could start looking for these civilizations that emitted radio frequencies. Now, unfortunately, yes, go ahead.
Well, I thought I read recently where this thing had been abandoned.
Oh, that's the next chart.
Oh, sorry.
Oh, but I see that Jack asked, what is the result of the Drake equations using current estimates? Well, so Jack, I mean, that's a great question. And, there are, of course, there's critics for everything, and there's certainly critics for the Drake equation. But the problem is that you could decide if you made the fraction of life-bearing planets on which intelligence, so you could, let's say that, for example, Titan, in 20, 40 years from now, we discover, we take a probe out to Titan, which, orbits Saturn, and we go through the ice. I mean, this is actually a water planet that's, covered with ice. We get through the ice, we go down to the surface of whatever the surface of that moon is, and we discover the equivalent of a mid-ocean ridge where there's bacteria. Okay, well, that's life. I mean, that would be amazing. And we would really, I mean, as a biochemist, I would want to know what its genetic code is. I mean, that's the first thing I would want to know. Okay, other people might want to know other things. I want to know, what is its DNA? What's its genetic code? But you could make this number right here, the fraction of life-bearing planets in which intelligent life emerges from where life actually appears, and you make that 0, and so all the rest of this doesn't matter. You see, Jack? So the question, I mean, so you can come up, I mean, you just make guesses, right? And some people make a guess that it's inevitable, and others make a guess that say, no, it's not ever going to happen. So you can find books that go both ways. Right? That you will I mean, they take a long time to say it, but basically they say life is inevitable, throughout the Milky Way, and others that say, no, we're the only one. And as Arthur C. Clarke said, either one is a frightening thing, right? That's amazing and frightening. But in any event, so let's see, where was I here? Oh yeah, so let's talk about SETI. So this is what this was used for from about 71, when it got turned over from the DoD to NASA. That's what it was used for, and they collected reams and reams and reams of data, but still only looked at about less than 1% of the stars in the Milky Way. Okay. Despite because it's a lot of stars, okay, out there. Now, in 2017, a hurricane named Maria hit Puerto Rico, and it snapped a lot of these cables. And it was dangerous. I mean, people could see this whole thing is going to collapse. And so, and remember that at this point, NSF owned it. So they decommissioned it really in 2017 and started to deconstruct it in a safe way. But then another hurricane came up, and this is what happened. Okay. And so it's totally decommissioned. I mean, they didn't get to complete the deconstruction. And so this is what it looks like now. There is thought of rebuilding it, and maybe they will, but it won't be the NSF or NASA or the DoD. It's going to be a consortium of countries that rebuild it, if it's rebuilt. It's in a perfect place. It's just the way that this is it's set in actually a sinkhole, big sinkhole, so that you could build this dome like this, and it could be supported easily. The whole dome could be supported. So, but it's collapsed now. Yes, Bruce.
Yes, Bruce. So in something like this, I've always been mystified. Can it look everywhere in the universe, or can it only look in one direction? Or how does it?
Well, okay, remember the Earth rotates, right?
Right. So
it's looking 360. And you get to point this thing. So you can't, you obviously you can't see through the galactic core where the supermassive black hole sits in, but you can see, theoretically, you could probably see about 80% of all the stars in the Milky Way, or 70% anyway. But unfortunately, we've only really looked at about 4%, I think, right now.
So,
Okay. So let's talk about the SETI Institute. It was incorporated as a 501c3 in '84. And before that, for maybe 20 years, actually, when NASA first took it over, let's see, NASA took over the Arecibo telescope in '71. So it's actually the SETI, there was a small project in NASA from 1971, and it only had 2 scientists that whole time. The same 2 scientists. They left NASA. They left NASA, and they Kenneth, could you mute?
Oh,
There we go. Thank you. Before that, there was these 2 scientists left NASA in '84 and formed the SETI Institute. Now, in the last 36, 37 years, its size has varied, but it's now combined with the Carl Sagan Center, and it's fluctuated. Okay, it's had maybe a couple hundred scientists. Now it has about a dozen scientists that are just working just on SETI. Now, this is the greatest thing in my mind about the SETI Institute. For 20 years, there was this thing called SETI at Home. I don't know if any of you know about it or actually used your computer to analyze radio telescope data, but in any event, it was an experiment. It was based in UC Berkeley. And so if you were connected to the internet, you could download a free program on your computer, and then a program, and then you would download radio telescope data that was collected by the Arecibo Space Telescope. And so you'd get about, a couple hundred megabytes at a time of data, and then you'd analyze it. The free program would analyze your data. And then it would send back the results back to UC Berkeley. And it would this program would run in the background. So if you were working in Word or something like that, it would stop. But as soon as you were, you went to eat lunch, or you ate breakfast, you went to sleep at night, then 100% of the CPU seconds, or virtually 100%, almost your entire computer capability would be analyzing the radio telescope data. And it was in operation for 20 years and more than 5 million people. And I was one of those people for about 2 years, okay, just for funsies. Just because you just collect data, right? I mean, it was just collecting data from looking at the universe, looking at the Milky Way, rather. And it worked for about, and Jack did. Hey, Jack, way to go. So you were one of those 5.2 million people too. That's great. But now you know, if you didn't, that it announced, so because of SETI, but there were other problems too. But it announced that the volunteer computing part of SETI would stop distributing work. In other words, the home computers now that even have the SETI at Home project software, it doesn't have any more data coming in. And it's in hibernation now, is what they've called it. Now, some people think it'll never come back, but there's talk that they'll start distributing work again. Maybe not so much on the Arecibo radio telescope in Arecibo radio telescope in Puerto Rico, but rather they'll be looking for at emanations from quasars and things like that. So, but any event, that's where that is. And so now that takes us to the concluding remarks. So let's see what I've got here. So here we go. So the universe is a big place. It's too big for us to actually visit. It's not like taking a trip to Italy or even Antarctica, okay? If anybody is a Star Trek, and you watch it, there's this one series called Star Trek Voyager, where a starship, somehow or other, and I didn't watch it very much, but I don't know the initial premise, but this starship ended up in the Delta Quadrant of the Milky Way. The Romulans and humans and Klingons, they live in the Alpha Quadrant. But this thing got blown away all the way on the other side of the galaxy in the Delta Quadrant. And so therefore they could never, ever have enough time. They wouldn't live long enough to get back to planet Earth. And so back to the Alpha Quadrant. And so that's the whole premise of this Star Trek Voyager, is that they were all by themselves, the only humans out in this other part of the Milky Way galaxy. And of course they had new aliens and things to interact with, but anyway. So the Milky Way is big. And we're not even talking about getting to other galaxies. That just is unimaginable. So, but we can sort of barely imagine getting to our nearest star. It's 4.3 light years away. But if we were going to do it with our current technology, we'd either have to hibernate for thousands of years, or we could travel as a population large enough to, maintain our genetics and just spend many generations traveling to Alpha Centauri. And so we can imagine that, but it's really hard. And so here's one comment I want to make about unidentified flying objects. If you look up unidentified in the dictionary, it does not include the word alien. So unidentified does not mean alien. Unidentified flying objects does not mean alien flying objects. It does not mean alien aerial phenomena, okay? Think about where these guys would have to come from. Now, granted, right? There's technologies we don't know about that we haven't invented yet. But so just as a recap for what we've done, we started with a history of UFOs and UAP in America. We reviewed just how big the universe is and how small our beautiful planet is in comparison. We reviewed some of the history of speculation, and it was speculation about ET life, and only about the last 60 years have we acquired any empirical evidence. And we looked at the Drake equation and the SETI Institute, and that takes us to questions and discussions. So there you go. Any questions, discussions? So Sue, do you still believe in extraterrestrial visitors to Earth?
Not in the scientific sense. What really has hit me, though, is the aspect that if the only entity that has life is Earth, what the heck are we doing to this beautiful marble?
Yes.
And I just keep thinking, just plastics, just that alone, let alone other stuff, going back to, what was it, The Graduate, plastic.
Yes, plastics, yeah.
That we're smothering the earth, and that if we're the only entity, wow, shame on us if we don't do something.
Well, yeah, that was sort of what Arthur C. Clarke said, if we are the only ones, we got to do better.
Yeah.
Well,
Yeah.
Rich has a question.
If we're not the only ones, let's hope we don't taste like shrimp to the other guys. Right? Rich, you have your hand up.
Yes. I've seen on TV lately on some of the sightings off of Virginia that the reason they're able to see them is because of better radar. How recent is that better radar? And what do you think of it?
Well, okay, so it depends on, that's a good, better radar from the site they're at. Okay, we've had X-band radars that were really powerful, and we put them on Kwajalein or up in Alaska. Kwajalein's in the South Pacific, just barely south. It's real close to the equator on the Marshall Islands. And then Alaska's up north. So why do you think we put our huge, really powerful radars down there? We're looking into space for bad things coming into our country. And we've always pointed in one direction. Now we point to three: Russia, North Korea, and China. Okay. So we've had the capability since mid-50s. In fact, that's one of the telescopes that the DoD built, was just to look at ionospheric radiation from missiles flying through the ionosphere, just on the radio frequency. Okay, it's not really radar, but it could detect emanations coming from, so it was be passive, right? You're just collecting data. You're not transmitting anything. It's not like a radar that transmits radiation and then gets the signals back. So that's called an active sensor. This would be a passive sensor. DoD's built that, right? DARPA built that telescope originally, and then when all of a sudden they didn't need it anymore, they just gave it to NASA, and it was NASA's headache. But in any event, so yeah, so the better telescopes, what you're talking about there, off of Wallops Island, I think, right? They did put a pretty powerful both X-band and S-band radar there in Wallops, but that technology has been around. Okay, there's nothing new about radar. I mean, I can't say that. There is new things, right? We have phased arrays now and all this stuff that simultaneously collects the data. I mean, it's really dramatic, the technological advances we made in radar, but the technology itself, the basic technology, is still the same. So in, I mean, it's true. We're looking at things, and anywhere you look, there's going to be some things that we don't know what it is, right? It's unidentified. That doesn't mean it's alien, though. Doesn't mean it traveled, 10 million light years or 10,000 light years away to get to here. And on a lark, it's just dive bombing one of our ships. It doesn't really make a lot of sense.
Okay, I've got another question, more into the UFO mythology. More than 50 years ago, I had a friend of a friend who saw a UFO at O'Hare Field in Chicago. And I'm wondering if anyone in this group has a friend of a friend, or a friend who's ever seen one, or you, Larry, have you ever had any experience with this UFO stuff?
Well, the most famous person that I have met who saw a UFO was President Jimmy Carter.
Cool.
Okay. but I don't really know. I don't have like a friend of a friend who's a ufologist, I guess. I don't know.
Yeah.
But Jimmy Carter, he says he saw a UFO.
Mm-hmm.
I mean, and there's no denying that. It was unidentified, right?
Yep.
Yeah. Okay. Doesn't mean it was alien.
That's right.
Yeah.
All
Okay.
right, I have a question.
Sure.
I changed my background here to be more appropriate. Anyway.
Starry Night.
Yeah, Starry Night, Van Gogh. Anyway, all of this, the Drake equation and everything, assumes our basic physics or understanding of what is. I mean, isn't there a possibility that these people out there have a total different construct that, that can enable them to go from 0 to 1,000 miles an hour and instantaneously, that violates our rules, but not theirs?
Well, okay, so first of all, the universe is uniform, right? There's the principle of universality. We don't teach it in high school or even in colleges very often, but the principle of universality is this: that if I look at a star in another galaxy, so let's say it's 150 million light years away, and I can detect its spectroscopy, right? Then I'm assuming, because of the principle of universality, that that star has the same elements that exist has the same periodic table as we have. And so I can look at that spectroscopy and I can say, okay, yep, it's got hydrogen and helium and lithium and oxygen. And, I can, just like I can look at our sun, right? And so that's how I can look so far away in a telescope. And I can predict, I can know the temperature, I can know the mass, I can know the composition of that star, because I assume that when I look at a spectroscopic analysis of that star, that I can read it just like I do our sun. Now, it turns out that helium was discovered on the sun before it was discovered on Earth, because we would look at the sun and we saw a spectroscopic fingerprint of an atom that we didn't have here on Earth. Ooh, and then actually there were two. There was another one called technetium. Okay. Now, we discovered helium just about the turn of from the 18th to the 19th century. I'm sorry, the 19th to the 20th century, right? In the early 1900s, we discovered helium. And then when we looked at helium on Earth spectroscopically, we said, there it is, there's helium, okay? So no more mystery. But there was still another element. It's technetium. Now, the reason why we can't detect, and we didn't discover this until after World War II, until after the nuclear age, where we could make technetium, because technetium, all the isotopes of technetium have a half-life very short. So when you make technetium, all the technetium that was made in the Big Bang that formed Earth has all disintegrated. It's all radioactively decayed. But we can make technetium now and get its radioisotope and get its spectroscopic fingerprint, and then we can say, there's that last element on the sun that we didn't know what it was. Now I know what it is. It's technetium.
So I guess maybe I am not really questioning, but is there a possibility that this universality is wrong? That there's something else?
Sure, absolutely. Until we get there, we will never know. Now, there's a great science fiction book. Let's see if I can find it here on my shelf right away. No, I can't right now. But anyway, we are in the slow zone, according to the science fiction book. Okay, we are in the slow zone where we can't exceed the speed of light. But outside of maybe 150 million light years away, there's the normal zone where you can go just about as fast as you want to. So the people outside of the slow zone, they stay away from our zone. They don't come in because they're stuck, right? They can only fly at the speed of light or below. They can't fly at hyperspeeds or whatever you want to. So yeah, there's science fiction to that extent, but we don't detect that with our telescopes. Okay, and we would certainly do it. Sue, you have your hand up.
Yes, so the UFOs that were filmed that we
Yes.
saw in the beginning. So
Right.
again, not, doesn't mean alien. Well, what
Right.
do they think, that's unidentifiable, but so who's making it and what might they be?
That's a good question. And if I was still in the Air Force, I might know some people that were actually looking at that. And if I got the right clearance, they might be able to tell me. If they do know, I have no idea. But I am pretty sure since they were going around Navy ships, that there are interested people that are looking into that. And somebody might know. In fact, they may not be unidentified to some people.
Yeah.
Okay.
Okay.
Or, and it who knows? It could be our guys that the Navy pilots didn't know about, right? The Illinois incident where we went through 6 towns. If you ever went to the Air Force Academy when a B-2 bomber flew over, you would see, and it could slow down really slow and then speed up really fast. You would imagine if I was at night and I was seeing this black triangular quiet thing really going slowly and then speeding up and going slowly, I might think that that's an unidentified flying object, but I'd recognize it as a B-2 bomber. Okay, so anyway, yeah, go ahead. You're muted.
Okay, I just remembered something that, let me lower that hand. So I have a brother who is retired from the Air Force and retired from communications in the government. And he, one time at my house where I lived in Castle Pines, he put a camera up in my backyard that could film stuff. Because we thought, well, we'll see a mountain lion or a bear or whatever,
Sure.
right?
Right.
And he came back to visit, and I know someplace on my computer I have this. If I find it, I'll share it with you. But he took that little thing out of the camera to look at, hey sis, what's been showing up? And he goes, what the heck is this? And he goes, only you would have something so woo-woo show up on your camera. He goes, I don't know what this is. And he kept trying to do all the things that he could do to manipulate this thing to look at it. But what appeared in my backyard looked like a disc with a protrusion out of the middle, which does not exist. And he couldn't find, as much as he'd enlarge it or whatever. And at the same time, there were these lights in the background. He goes, they're not eyeballs. They're not and there were these like little light globes. And he goes, this is plain as can be on the film. He goes, but I don't have a clue as to what it is.
Did you have any indication of how far away it was?
Oh, it was close, like I'd say 40 feet.
Oh, really? So
I
it
mean,
wasn't very big. So it wasn't very large.
It wasn't very large.
Okay.
And it was, he couldn't figure out what it was. Like, let's say if somebody was playing a trick or some kids, and, of course, there's not a lot of kids in the neighborhood there.
Right. Sure.
And they're going to go through the forest and set this thing up, but it was and he goes, and the lights, the little globes, he goes, it's not flashlights. So,
Wow.
And if I can find it, I know it's someplace deep within my computer. But if I find it, I'll share it with you sometime.
Okay, that's cool.
But it's going to be
Right.
interesting. It's like, oh, what is it?
Yeah.
I'm about at the point where I have to adjourn to the church to start working on trees.
That's true.
Can you, as co-host, wrap this?
Yeah,
up?
I could stop the meeting if I wanted. Oh, there's a chat. Let's see, who's the chat here? Oh, wait a minute. Chat.
It's gone, but anyway.
It's gone now, isn't it?
Yeah.
Oh, there it is. Oh, Paul Erickson said I got to run. Thanks.
He's
Okay.
probably at the church by now.
Yeah, he probably has to go to church. Yeah. Okay. All right.
So is there more? This is terrific. And I'm perfectly willing to let Larry continue as long as the rest of you want to.
Well, I don't know if there's any more questions or not. Any more comments or anything?
Absolutely astounding. I've been getting calls in the meantime. People were confused about what time we started. So I'm very, very glad that we recorded it, and we'll be.
Yeah. Okay. Well, then why don't you go ahead and stop the recording now? I guess I can actually stop it, Bruce, because I'm a co-host. So I'm going to stop it now.
Okay, or I can.